Thank you. Great presentation. So as data scientists know, 70 to 80% of our work is cleaning and preparing data. And I know one of the slides alluded to this challenge of if everyone's got their own local data sets, are they going to be cleaning and preparing it the same way? And how would you disseminate, standards for data quality to all those local pieces before you bring it together? Just wondering if you had some thoughts on that.
I might take that.
Sure.
It's a very good question. I think one thing to bear in mind is that at the moment, we're not thinking about solving problems that are sort of generic to the question of pooling data. So it's not magic. The data quality problem is a problem even if you decide to pool data. But one way to think about this is that by making a low-friction environment for beginning these kinds of collaborations, it gives you an opportunity to discover the issues. And of course, the tools that we can build in a distributed way will have the usual sorts of diagnostics for data quality in it. And the point is you can get started, maybe get a small win, and say, okay, it's now worthwhile for the sites that, for example, haven't been that careful about doing follow-up to go back and remedy that. As opposed to a situation in which you say to people, well, in order for you to pool your data in some place, it's going to be memorialized and so forth, permanently stored. You will have to do a perfect job from the beginning. So this is a way of maybe getting the sites to find it worthwhile to do the work that they will need to do, and of course then build in the tools to discover the fact of that need.
Are you suggesting that there's a way to use this that makes it almost an interaction or collaboration tool as opposed to a more formal one-shot thing?
Absolutely. Yeah.
Good point.
Other questions or comments? I think another reason why I like this example is because it has something to do with the cloud. And we know that understanding both private and public clouds and ways to use them are of concern and interest to many of you in this room, as well as, of course, the large cloud providers as they try to understand the business models and how to actually make the cloud useful. So that's a potential area of further focus in the data science initiative's interactions with all of you. Trying to understand the cloud, what does it mean, when should you use public clouds versus private clouds, and so on. And so if, in fact, that's a topic of interest, we'd love to hear about that from you. Other questions or comments for these speakers today? Yes, please.
So naturally begs the question about, what happens beyond linear models. So the homomorphic encryption is a critical piece of it, and then works with certain simple linear models. The regression models that came out didn't look that interesting, and a lot of other people are saying they would use deep neural networks, which are highly nonlinear and very deep. So what do you do? I mean, one side of data science is saying, we are not going to do more advanced features so we can linearize problems to begin with. We're going to have neural networks and other things discover those features. And the other side is saying, we have all these clever techniques that use encryption, which works well on linear models. How do you reconcile that?
I'll answer that in two ways. For example, the paradigm that you have described is actually, I only described a part of it. I think there was mention of something called ADMM, for example, which is actually a distributed convex optimization algorithm. There is no real practical difficulty in actually doing that also. That it's actually built into the system. So you could do an ADMM model fit where you can formulate models, even generalized linear models and other things. That way you could actually do that also as a convex optimization problem. That's one part. The second part is that I still see, at least for speaking as a statistician, in the context of precision medicine and so on, I don't think that, even if you have the EMR, it's really hard to sort of completely clean up your EMR, apply a whole bunch of predictors in a model. In other words, you can't clean up all the data. So you're generally going to be limited to a small set of features. So I agree that we're not thought about deep learning or anything of that nature, but I think that I still think statistical models are important. The inference part is important, and I think that this is one small step towards that.
If I can just add to the comment there, Our scope is looking at distributed optimization algorithms that we can run in this fashion. And that's a very wide range of problems. Any machine learning problem, including the deep neural nets problems underneath are, for example, a gradient descent. We have internally developed gradient descent, distributed gradient descent algorithms that are efficient within a local cluster with the goal of improving scaling within a computation of large data. Here, the goal is different, but I think the methods we can transfer from the local cluster, big data realm to this distributed computational realm. So I think pretty much any model that fits into that optimization framework would apply.
Other questions or comments? Yes, David.
So I think this is a question for John, but any of you
Sure.
could take it. So this multi-tenancy model where you don't actually see the data, but you can run your models against it.
Sure.
What sort of, do the data models, the data stored at each of those sites, do people have to pre-agree of what that data should look like, how it should be structured? Is it unstructured data? In other words, if I'm going to run my model against all these other data sets, how do I know what's out there? Is there some, beyond people emailing data models back and forth to each other, is there anything built into the system that enables, in other words, could you have your tools running and simply go ahead and find the data across these tenancies, or do you have to know it's there and pre-train your model to go grab those data sets?
This is good. This is a very good question, and it's something that we haven't said a lot about, and we haven't really included much here that covers that. Our concept here is that the clinician and statisticians get together and agree on a schema and a model. And you saw that in one step of Naris's slide. I think there is some really interesting work there in what it means to build a set of compatible models. How much freedom do you have in terms of how you can align in terms of, for example, the semantics of the variables. The one small control I think you have is that you do see the results coming back individually from each site. And if you're getting a statistic back that is not informative, then perhaps you can say, I disqualify this, or I don't include it in the final. But there's probably something more to say about how we come to agreement here.
So I think that at the current stage, it's quite preliminary. There's not that much built into the system, but there is some sanity checking that is done and so on about the variables that are expected. And the model definition kind of encapsulates that, but there's more work to be done.
This is really interesting. I think one of the things that we learned from the few questions following the talk is not only do people care about data and massive experiments and sharing data, but whatever capabilities this solution has, it's clear that the audience wants more. They want a broader range of models, and this, which was designed around close collaborators between people who know each other, clearly there's also an interest in ways to expand that to people who don't know each other and wondering how you do the quality control and semantic checking in more challenging cases like that. Maybe even in the future, we'll have a complete democratization of data sharing, something that looks like Twitter, dare I say it, for sharing and collaborating on data, and maybe this is just a first baby step in that direction. Please join me in thanking all three of our speakers.